Example 2. Fewer than 30% of adults have sleepwalked. A study of sleepwalking or nocturnal wandering was described in Neurology magazine, and it included information that 29.2% of 19,136 American adults have sleepwalked. Would a reporter be justified in stating that fewer than 30% of adults have sleepwalked? Let's use a 0.05 significance level to test the claim that for the adult population, the proportion of those who have sleepwalked is less than 0.30. Okay, so we first want to identify the following. We know that the sample size n is equal to 19,136. The point estimate in this problem is 29.2%, which is 0.292 as a decimal. The proportion is going to equal 0.30 because that is the claim. And the alternative to the proportion, Q, is 1 minus P, and 1 minus 0.30 is equal to 0.70. Okay, so the requirements. The requirements state that the sample is a simple random sample, which it is. Number 2, there is a fixed number, which is 19,136 of independent trials with 2 categories. A subject has sleepwalked or has not. And then number 3, the requirements of n times p is greater than or equal to 5 and n times q is greater than or equal to 5 are both satisfied with n is equal to 19,136, p is equal to 0.30, and q is equal to 0.70. Well, if we plug those values in, 19,136 times 0.30 gives us 5,740, which is greater than 5. And n times q, 19,136 times 0.7 is equal to 13,395.2, which is also greater than 5. Therefore, the 3 requirements are satisfied. Okay, now we can start. We're going to state the claim and the opposite of the claim. Well, we know the claim states that the proportion of those who have sleepwalked is less than 0.30. So, since it's less than 0.30, that means that the opposite would then be greater than or equal to 0.30. So, since this represents and contains the equal sign, then that tells us that the equal sign is always in the null, so p is going to equal 0.5. Therefore, the claim then of p, which is less than 0.30, is then going to be in the alternative hypothesis. So the alternative hypothesis would be that p is less than 0.5. Now we can identify the null in the alternative hypothesis. So again, the null is that p is equal to 0.5, and the alternative is that p is less than 0.5. Now in part 3, we want to use the alternative hypothesis to determine whether it is a left, right, or two-tailed distribution. Well, because the alternative has a less than sign, we would say that this is a left-tailed distribution since the alternative hypothesis contains the inequality less than. Now in part 4, it says select the significance level alpha. Well, in our problem, it tells us to use 0.05 for the significance level, so therefore alpha is going to equal 0.05. And now number 5, we want to find a test statistic for testing the claim about a proportion. Okay, so let's recall that we have, from the beginning, we identified the sample size, the point estimate, p, and the complement of p. So now we're going to plug that into our test statistic formula. So we know our point estimate is 0.292, and then we know that the value of p is 0.30. So we know that under the square root sign we have 0.30. We know that the complement of p is 0.70, and then we know that the sample size is 19,136. So let's go ahead and plug this in our calculator. So in our numerator, we're going to take parentheses 0.292 and then subtract 0.30. And this is what we get in the numerator. Now we're going to go ahead and divide that by the second square root, and then we're going to put in parentheses 0.30 and then times 0.70 parentheses, and then divide that by left parenthesis 19,136, and then right parenthesis, and then shift, and then press enter. And we should get rounded to 6 decimal places, negative 2.414938. And we want to round this to 2 decimal places, which would be negative 2.41. So therefore, that's going to give us our test statistic. Okay, so now what we want to do is we want to first use the p-value method, and then we're going to then use the critical value method. So we're going to use the p-value method first, and we're going to draw the curve and then label. So by using the p-value method, we're going to go ahead and then draw our bell curve and then label everything that we would like to label for that. So we know that the mean is going to be 0 since our test statistic is in a Z format. So we know it's a left tail, so that means that our test statistic is going to be to the left of 0. And then that is Z, which is equal to negative 2.41, since that's what we found here. So again, this represents the test statistic. Okay, and so what we want to be able to do is we want to be able to find out what is the area or the probability that's to the left of that, which is going to represent our p-value. So therefore, the p-value is going to equal the probability of Z being less than negative 2.41. So we can either use this, we can determine this by using the table or StatCrunch. We're going to use StatCrunch. Okay, so let's go ahead and we're going to go in our normal calculator. So we're going to go to Stat, Calculators, and then scroll down to Normal. We know that we have a mean of 0 and a standard deviation of 1. Since we want it to the left, we want to make sure this is less than or equal to. And then we're going to put in our test statistic of negative 2.41 and then select Compute. And so therefore, we're going to get our p-value here, and then we're going to round that to 4 decimal places. So if we round it to 4 decimal places, we're going to get 0.0080. So we get 0.0080. So now that we find the p-value, now we want to be able to then in part 7 make a decision. So we reject the null hypothesis if the p-value is less than or equal to alpha, and we fail to reject the null if the p-value is greater than alpha. Well, comparing this, we get 0.008, and that is less than 0.05. Therefore, we reject the null by using the p-value method. Okay, now let's take a look at the critical value method. So the critical value method, we want to find the critical value for the significance level of 0.05. Well, we know that alpha is equal to 0.05, and so that means you want to find the critical value of when this area is in the right. So let's go ahead and just use our StatCrunch calculator here. We'll just go ahead and go to Options and then Refresh. So the critical value for this is where it's going to be located to the right. So if we take 0 and then 1, and then this is going to be greater than or equal to, we're going to put in 0.05. Okay, this critical value is on the right, and what we get is 1.645. Okay, but we're concerned about the one on the left. Well, the one on the left would then be negative 1.645. So that means that the one on the right is 1.645. So when you think about this is the one on the right, And then the critical value on the left is the negative version of that, which is negative 1.645. So that's the one that we're going to want to use for the critical value. So let's go ahead and draw our bell curve with the critical value. So we know that our critical value is negative z alpha divided by 2, which is equal to negative 1.645. Okay, let me rewrite that again. So we have z alpha divided by 2, which is negative 1.645. And so we want to determine the critical region, and the critical region is here on the left side. So this is our critical region. Now we need to take a look at that test statistic. Well, that test statistic is negative 2.41. And that means it's going to be in there, in the critical region. So z, which is equal to negative 2.41, is the test statistic. And therefore, that falls in the critical region. So, for the critical value method, we reject the null if the test statistic is in the critical region, and we fail to reject the null if the test statistic is not in the critical region. And because of the fact that the test statistic of negative 2.41, and that should be negative 2.41, is in the critical region, and so therefore we're going to reject the null hypothesis. Now we want to be able to state the conclusion. Okay, now recall that the original claim does not include the equality, then you reject the null. Well, if we take a look at the claim, okay, the claim, okay, it says the tested claim for those who have sleepwalked is less than 0.30. This doesn't have an equality, this has a less than. And since it has a less than, that means it doesn't include the equality, and we've also rejected the null. So that means it's going to apply to the first one where it says there is sufficient evidence to support the claim. So we would say that because we reject the null hypothesis, we support the alternative hypothesis. So we therefore conclude that there is sufficient evidence to support the claim that fewer than 30% of adults have sleepwalked. So let's just verify that here, okay? The original claim does not include equality, and then we reject the null. So we would say there is sufficient evidence to support the claim. So there is sufficient evidence to support the claim of that fewer than 30% of adults have sleepwalked.